Okay, today we are going to solve a problem involving radioactive decay. This question involves a sample of an unknown radioactive isotope that initially weighs 5 grams. After 1 year, the mass decreases to 4.27 grams. So, for the part A, firstly we have to extract the data provided in the question. And then we have to use the formula after calculation R equals to 0.15782, and that is our decay constant. Okay, next we have to calculate how quickly the mass is decreasing at t equals to 1 year. When we use the formula and substitute the value, we will get the answer with the negative 0.6739 gram per year, and the negative sign indicates a decrease. So the rate of mass loss is approximately 0.674 gram per year. And then for the second question, part B, we calculate the half-life using the formula, and after substituting the values, we'll get the answer 4.392 years. So the half-life of isotope is approximately 4.39 years.
Question 2 is about cell culture. At first, we will determine differential equation for exponential growth of cells. Then we will forming the general equation by integrate both sides of differential equation. In the situation, time equals 3 hours and number of cells equal double of the initial number of cells, we can find the value of k. Thus, we complete the general equation. By using the general equation and the second situation, which is 5,000 cells equals n, and n naught will be 30,000 cells. For question 3, we form general equation by integrate the given rate equation and substitute value of k to obtain the complete general equation. And given situation to consume 90% of the initial butyl chloride in this reaction, so we can find the rest of butyl chloride after the reaction, which is 0.1 of the initial butyl chloride. And we substitute all the requirements into the general equation, we can find the time taken.
Okay, now I'm gonna explain about the question number 4. A capacitor with a capacitance of 5.0 coulombs per volt hold an initial charge of 350 coulombs. The capacitor is attached to a resistor with a resistance of 8.0 volts second per coulombs. Part A. How quickly will the charge held by the capacitor initially decreases? As they said below, t equals to 0. So the rate of change of charge will be formulated as qt equals to q0 exponential negative 1 over t. By differentiating this equation, we will get negative q0 over t. As we know, t equals to rc. So by substituting the value of r and c, we will get 40. And then we will substitute the value of 40 into the differential equation. We will get negative 8.75 coulomb per second. So the change decreases at the rate of 8.75 coulomb per second initially. Part B. How quickly will the charge be decreasing after 20 seconds? So the t will be equals to 20. Qt equals to q0 exponential negative 1 over t. By substituting the value of t equals to 20 into the formula, we will get 212.286 coulomb. And then we have to substitute this value into the differential formula. So we will get negative 5.31 coulomb per second. The rate at which the charge decreases after 20 seconds is 5.31 coulomb per second.
Question 5 is about cooling of a warm body placed in a cold environment. Firstly, we need using Newton's law of cooling to solve the question. From that, we get the formula T equal to Te plus C exponential negative kT. From the question, we get the initial temperature is 25 degrees Celsius. After 10 minutes, the temperature is changed to 20 degrees Celsius, and we also get the internal temperature, which is 5 degrees Celsius. Then we find the value of C, which substitute the initial temperature 25 degrees Celsius into the formula. After that, we find the value of K, we substitute the temperature after 10 minutes, which is 20 degrees Celsius, and T equal to 10 to get the value of K. Finally, we find the temperature after 1 hour with T equal to 16, and we get the temperature 8.6 degrees Celsius. For question 6, we need method separation of variable to solve the differential equation to find the general solution. We know the initial mass and k from the question. We need to substitute the initial mass into the general equation that we find to get the value of C. Lastly, we substitute the value of k that given in the question and the value of C that we find, and let the mass as 0 since the black hole need evaporate completely to get the time.
Question 7 is about velocity of an object moving through a fluid. Then it can be modeled by equation dv dt equal to negative kv squared, where k is a constant. Then we need to find general solution to this equation. From the equation, we can use separation variable to get general solution, which is v equal to 1 per kt plus c. Question 7b asks what will the velocity be after 10 seconds. First, we use the initial velocity t equal to 0, v equal to 40, substitute into the general solution to find c is 1 per 40. Then velocity after 2 seconds means that t equal to 2, v equal to 30 to 5k is 1 per 240. Then substitute c and k into general solution. Then we can find velocity after 10 seconds. Question 8 is about population of bacteria. Now we need to find how large will the population be 30 minutes later. We can use logistical formula to solve this question. Given that L equal to 100,000 and initial population equal to 5,000, we can find A equal to 90. And also given that the rate equal to 400, then we can find the K. Substitute LA and K into the general solution, we can find population after 30 minutes now. Question 8b asks when will the population reach 18,000. We substitute at P equal to 80,000, then we can get the time.
Question 9. A. First, we separate the variables of differential equation to find the general solution. B. Question given initially rate of change and initially of the water to find the value of K and C. How long will it take for tank to drain completely? It is when V equal to 0. Then the time is 33.28 minutes.
Question 10. The compass equation has been used to model the growth of Marinette thermals. The equation states that dP over dt equals to Kp multiplied with rho P mass minus rho P, where P is the population of cancer cells and K and P mass are constant. Question A. Use separation of variables to find the general solution to this equation. Since this question states that by using separation of variables method to find the general solution, hence we just integrate as usual. We put the P terms in the right hand side and T terms for the right hand side. And then we use integration by substitution to solve this problem. Let U equals to rho P mass minus rho P. So we get du equals to negative 1 over P dP. Then we substitute into this problem so we can integrate separately easily. So the final answer is P equals to P max exponential to A exponential to negative KT, where A equals to negative exponential to negative C. Question B. A thermal with 5,000 cells is initially growing at a rate of 200 cells per day. Assuming the maximum size of the thermal is P max equals to 100,000 cells. How large will the thermal be after 100 days? First step, we find the value of K. Since we have dP over dt equals 200, P max equals to 100,000, we assume T equals to 0, then T equals to 5,000. So we get K equals to 1 over 25 ln 20. Step 2, from general solution, we have the value of K. So we just substitute into this general solution. So we get constant A equals to ln 0.05. And finally, we can find the population of cancer cells P when T equals to 100. So we get P approximately to 45,468 cells.
Question 11. The rate of change of question is dt per dt is equal to negative k t minus 60. To find the general solution, then when t is equal to 79, t is equal to 0, and when t is equal to 68, t is equal to 3. To find the value of A and K.
Find the time of the normal body temperature is 98.6. It is T is equal to negative 2.46. Since the time of death is approximately to 2.46 hours before 3 p.m., therefore the time is 12.33 p.m.
Question 12 involves a tank containing brine solution. To fulfill the given task, the rate of change in amount of salt should be determined first. The rate of change in amount of salt refers to the net flow rate of the brine solution. Both of the inflow rate and outflow rate is equal to the multiplication between the solution concentration and the rate of change in its volume. However, the volume inflow rate is higher than the volume outflow rate. It indicates the volume of the solution increases with time. This is considered in the outflow rate of brine solution. After integrating the equation, it becomes a function for the amount of salt in any time. The constant of the function is obtained through calculation using initial value of the amount of salt. To calculate the concentration of the solution when its volume reaches maximum, the time when this situation happens should be found. The obtained value is substituted into the function to get the amount of salt. Finally, the amount is divided with the volume to calculate its concentration. Question 13 involves a single tank containing water with dissolved salt. The rate of change in amount of salt is determined first to find the amount of salt in the tank at any time. It refers to the net flow rate of the mixture in the tank, as same as in question 12. However, in this question, the inflow rate in volume of brine solution is same with the outflow rate of the mixture. Therefore, the volume of the mixture in the tank remains unchanged as time passes. After integrating the equation for the rate of change in amount of salt, the function for the amount of salt is found. The constant is calculated by substituting the initial value of the amount of salt.
Okay, now I'm gonna explaining about the question number 14. Suppose that a culture of bacteria has initial population of n equals to 100. If the population doubles every 3 days, determine the number of bacteria present after 30 days. How much time is required for the population to reach 4,250 in number? As they mentioned earlier, the initial n will be 100 and t equals to 3. By substituting the values into the formula of nt equals to n0 to power of t over t, we will get 102,400 bacteria. As they are asking for after 4,250, we have to substitute the values into the formula. We will get the t equals to 16.23 days. Thank you.
Question 15. The population of the community is known to increase at a rate proportional to the number of people present at time t. If the population has doubled in 6 years, how long it will take to triple? First step, we find the value of p0. When t equals to 0, we assume t equals to 1 since it is initial, so we get p0 equals to 1. Step 2, we find the value of k. When t equals to 6, we assume that p equals to 2 since it is double, so we get constant k equals to ln 2 over 6. And finally, we can find the time taken t. We assume p equals to 3 since it is triple, so we get t equals to 9.5098 years.